Hello everyone, welcome to today's session, which is based on machine learning project introduction, where we will see a lot of machine learning projects which was developed by Google, Facebook and many more companies. So let's start our session. The past year has seen a lot of great examples for machine learning and many new high impact applications of machine learning discovered and brought to light, especially in healthcare, finance, speech recognition, augmented reality, and much more complex 3D and video applications. Now, natural language processing was easily the most talked about domain within the community with the likes of ULMFIT and but being open sourced. So let's have a look at some of the amazing machine learning projects which are open sourced and the code is available for you, and those are discussed in 2018 to 9 in Spectrum. So the first and the foremost is TensorFlow.js. Now, machine learning is the browsers or fictional thought a few years back and a stunning reality now. A lot of us in the field are welded to our favorite IDE, but TensorFlow.js has the potential to change your habits. It's become a very popular release since its release earlier this year and continues to amaze with its flexibility. Now, as a repository states, there are primarily three major features of TensorFlow.js: develop machine learning and deep learning models in your process itself, run pre-existent TensorFlow models within the browser, retrain and find these predictions model as well. And if you are familiar with Keras, the high-level layer API, which seem quite familiar, but there are plenty of examples available on GitHub repository. So do check out those legs to quicken your learning curve. The next thing we have discussed is a detectron. That was developed by Facebook and made a huge splash when it was earlier launched in 2018. Those developed by Facebook's AI research team, which is FAIR, and it implements the state-of-the-art object detection frame. It is written in Python and has helped enable multiple projects including the DensePose. Now we'll know what exactly is DensePose after this example, and this repository contains the code of over 70 pretend models. So it's a very good open source for small guys. So to check it out now, the moment I talked about DensePose, that's the next one I'm going to talk about. So DensePose is dense human pose estimation in the wild, but the code to train and evaluate your own DensePose using our CNN model is included here, and there are notebooks available as well to visualize certain sports cocoa datasets. Now, the next on our list, we have de-painterly harmonization. Now, I want you to take a moment to just admire the above images. Can you tell which ones were done by a human and which one by a machine? I certainly could not. But here the first frame is the input image, the original one, and a third frame, as you can see here, has been generated by this amazing technique. The algorithm has an external object of your choosing to any image and manages it to make it look like nothing touched it. It is really fun. But talking about images, we have an image out painting. Now, what if I give you an image and ask you to extend its boundaries by imagining what it would look like when the entire scene was captured? You would understandably turn to some image editing software. But here's the awesome news: you can achieve it in a few lines of code, which is the image out painting. This project is Akira's implementation of the Stanford image out painting paper, which is an incredibly cool and illustrated paper. And this is how most research papers should be. Now, let's talk about audio processing, which is another field where machine learning has started to make its mark. It is not just limited to generating music. You can do tasks like audio classification, fingerprinting, segmentation, tagging, and much more. And there is a lot that's still yet to be explored. And who knows, perhaps you could use this project to pioneer your way to the top. Now, what if you want to discover your own planner? Now, that might perhaps by overstating things a bit, but the astronaut repository will definitely get you close. The Google Brain team discovered two new planets in the summer 2017 by applying the astronaut. It's a deep neural network meant for working with astronomical data. It goes to show the far ranging application of machine learning and was a truly monumental development. And now the team behind the technology has open sourced the entire code. So go ahead and check out your own planet. And who knows, you might even have a planet on your name. Now, I could not possibly let this section pass by without mentioning the BERT, the Google AI released, has smashed records on his way to winning the hearts of NLP enthusiasts and experts alike following ULMFIT and ELMO and BERT really blew away the competition with its performance. It obtained a state of art result on 11 NLP tasks apart from the official Google repository. There is a Python implementation of birth, which is worth checking out whether it makes a new error or not in natural language processing. The thing we will soon find out. Now, AdaNet. I'm sure you guys might have heard of it. It is a framework for automatically learning high quality models without requiring programming expertise since it's a Google invention. The framework is based on TensorFlow and you can build simple models using AdaNet and even extend it to use to train a neural network. Now, the GitHub page contains the code. An example the API documentation and other things to get your hands dirty. Trust me, Auto MI is the next big thing in our field. Now, if you follow a few researchers on social media, you must have come across some of the images I'm showing here in a video from a stick human running across the terrain or trying to stand up or some sort. But that, my friends, is reinforcement learning and action. Now, here's a signature example of it, a framework to train a simulated humanoid to imitate multiple motion skin. So, this is all about the machine learning projects. We have more projects in machine learning. So, let's have a look at the top 10 skills are required to become a successful machine learning engineer. So, starting with programming language, Python is the lingua franca of machine learning. You may have had exposure to buy them, even if you weren't previously in programming or in a computer science research field. However, it is important to have a solid understanding of classes and data structures. Sometimes Python won't be enough often. You will encounter projects that need to leverage hardware for speed improvements. Now make sure you are familiar with the basic algorithms as well as the classes, memory management, and linking. Now, if you want a job in machine learning, you will probably have to learn all of these languages. At some point, C++ can help in speeding code up, whereas R works great in statistics and plots and Hadoop in Java based. So you probably need to implement mappers and reducers in Java. Now next, we have linear algebra. You need to be intimately familiar with matrix vectors and matrix multiplication. If you have an understanding of derivatives and integrals, you should be in the clear. Otherwise, even simple concept like gradient descent will elude you. Statistics is going to come up a lot. At least make sure you are familiar with the Gaussian distribution, means standard deviation, and much more. Every bit of statistical understanding beyond this, the theories help in learning about algorithms, great samples, and naive Bayes, Gaussian mixture model, and hidden Markov models. You need to have a firm understanding of probabilities and stats to understand these models. Just go nuts and study major theory. And next, we have advanced signal processing techniques. Now, feature extraction is one of the most important parts of machine learning. Different types of problems need various solutions. You may be able to utilize really cool advanced signal processing algorithms such as wavelets, shearlets, curvelets, and bandlets. You need to learn about the time frequency analysis and try to apply it in your problems. Now, this skill will give you an edge over all the other skills. Now, this skill will give you an edge while you're applying for a machine learning engineer job or others. Next, we have applied maths, a lot of machine learning techniques. There are just fancy types of functional approximation, but now these often get developed by theoretical mathematicians and then get applied by people who do not understand the theory at all. Now the result is that many developers might have a hard time finding the best techniques for the problem. So even a basic understanding of numerical analysis will give you a huge edge having a for understanding of algorithm theory and knowing how the algorithm works. You can also discriminate models such as SVMs. Now you will need to understand subjects such as gradient descent, convex optimization, Lagrange, quadratic programming, partial differentiation equations, and much more. Now, all this math might seem intimidating at first if you have been away from it for a while, but machine learning is much more math intensive than something like front-end developer. Just like any other skill, getting better at math is a matter of focus practice. The next skill in our list is neural network architectures. We need machine learning for tasks that are too complex for humans to code directly. That is, tasks that are so complex that is impractical. Now, neural networks are a class of models within the general machine learning literature, or neural networks are a specific set of algorithms that have revolutionized machine learning. They are inspired by biological neural networks, and the current so-called deep neural networks have proven to work quite well. Well, the neural networks are themselves general function approximations, which is why they can be applied to almost any machine learning problem about learning a complex mapping from the input to the output space. Of course, there are still good reasons for the surge in a popularity of neural networks, but neural networks have been by far the most accurate way of approaching many problems like translation, speech recognition, and image classification. Now, coming to our next point, which is a natural language processing. Since it combines computer science and listed, there are a bunch of libraries like the NLTK and the techniques such as sentimental analysis and summarization that are unique to NLP. Now, audio and video processing have a frequent overlap with natural language processing. However, natural language processing can be applied to non-audio data like text voice, and audio analysis involves extracting useful information from the audio signals themselves. Being well versed in math will get you far in this one, and you should also be familiar with the concept such as the fast Fourier transforms. Now, these are the technical skills that are required to become a successful machine learning engineer. So, that is all about the machine learning course. Thank you so much for watching our video.